This is the homework, the 4-step method. In problem 1a, I know the side length of the cube is 2 centimeters. I know the mass is 20 grams. And I'm trying to find the volume of this cube. So I would put a little box around V to find volume, and just a second later, I'm going to put a box around D because in the next part I'm going to solve for density. Okay? So all 3 equations have volume in it, but the one I'm going to choose is the volume of a cube equation. This would be 2 centimeters cubed, or 2 centimeters cubed, or 8 centimeters cubed. Here we go. Now, once I get this information, I can feel free to use it in part B of the problem. There's always follow through allowed. In this case, I'm trying to find the density. Only one equation has density, so I know which one I'm going to use. 20 grams over 8 centimeters cubed gets me 2.5 grams per centimeters cubed. Okay. This little number that's next to each problem is the solution. That way, if you're at home, you can follow along and you know what your answer is as you go. What I probably won't do every time is I won't write out my full answers for these justify, because you don't want to sit here and watch me write. That's boring. But I will explain it in words. So in this case, this has a density of 2.5. That means it will sink because it's more dense than water. And up here earlier, it says things that are less dense will float and things that are more dense will sink. For the same reason, 2A also sinks. Its density is 1.6 and water's density is 1. So its density is greater than water and it will sink. Now, I had a lot of people in class ask me about this calculate the volume of a sphere, because you're like, oh, volume of a sphere. That's 4/3 pi r cubed. But we don't have the radius. So here's why your knowns and unknowns are important, guys. If I look at my knowns and unknowns, I know the mass is 15.6. I know the volume is 1.6. Or sorry, the density is 1.6. See? Unedited, real life. So now I can find the volume, and I can use the volume to find the radius. So this equation is not going to work because we don't know the radius yet. But all the other equations do have volume in it. I can't use this one because that's the volume of a cube, but I can use the density equation and solve for V. So this is 1.6 equals 15.6 over V, multiply by V on both sides. 1.6V equals 15.6, divide by 1.6 on both sides to give us 9.75 centimeters cubed. I can then use that number to calculate radius. I had someone ask, they were like, well, I have my volume, right? And they're trying to find the radius. So we write down our equation, then substitute. And they were like, well, I did 9.75 and then took the cube root. But you actually can't do that yet, guys. Order of operation says deal with the multiplying, dividing first, then the roots. So let's do that. I'm going to multiply 3 to the other side. And if you want this written out neatly, this is written out more neatly in the actual answer key. So divide by 3, or sorry, multiply by 3, divide by 4 to get rid of the 4/3. Divide by pi to get rid of that pi. And that leaves r cubed. 9.75 times 3 divided by r cubed gets me this 2.33 is equal to r cubed. And if you're unfamiliar with how to do a cube root, I would enter this into my calculator. Whichever calculator you use is 2.33 to the power 1 divided by 3. A cube root is to the 0.333 power. to the 1/3 power, and that's where I got the 1.33 centimeters. And if your answer is a little bit off from mine, no big deal because we all rounded differently. D, lots of questions on D, but I think it's because the wording's a little complicated. So I want you to picture, since I'm not going to write this out, I want you to picture a really light wood. Think like a cork, something that's going to float. It has really low density. But an iron ball of the same mass would be much smaller. If these have the same amount of mass, whichever one is more dense has the smaller radius. Whichever one has the larger density takes up less volume. The heavier thing, it just has more matter packed into a tight, tight, tight volume. Ha! So that means if volume goes down, radius goes down. So I had B is less than A. For 3, ranking task, C and D have the same volume, but they all have the same mass. So whatever density it is, C and D must have the same. Density and volume are inversely related. If an object is more dense, it takes up less space. So B must be the most dense, then A, then C and D. C and D might float because they have less mass per volume, but B would sink to the bottom because it has more mass crammed into a little tiny volume. So page 1 and 2 is all practicing a certain set of equations plus relationships. And you'll see that equations are really just ways to describe relationships without saying words. So you'll see that this one, we're trying a new set of equations plus relationships. 3 equations, 2 relationships. We can do this. And I would suggest doing this by identifying your knowns and unknowns, like your key words. Rest means 0 meters per second. The final velocity, VF, is 27 meters per second. And if you ever get stuck in a problem, I promise taking the time to do knowns and unknowns is absolutely a use of your time. It is a good use of your time. So I'm trying to find acceleration and distance, right? In part B, I'll find distance. So guys, I need an equation that has VF, VI, T, and A, right? The only one that has that and no other things is equation 1. Picture yourself, I'm picking out the equation that has everything that I am given in the problem and the thing I'm looking for with no extra. That's how I pick out my equations. So that's 27 equals 0 plus I don't know what A is and 2.6. Divide by 2.6 to the other side. 27 over 2.6 gives us our 10.4 meters per second squared. And to me that sounds about right. Accelerations of cars shouldn't be significantly greater than gravity. This one is greater than gravity, but not by much. If you have accelerations in the tens of G's, think in the thousands of meters per second squared, that's causing irreparable damage to your human. So it's not that. So this is a reasonable number. If acceleration is too high, that causes bodily damage to the riders. So we don't want that. Okay? So how far does it travel during acceleration? Well, now that I solved A, I could actually choose whichever equation is left to work on. Both equations have enough information to solve now, and it doesn't matter which I choose. So I'm only going to pick one of them to show you in this video for sake of time, and the one I think is easier to solve is this one because I'm already trying to find distance, and that solves for distance. Right, plus VI is 0. So if VI is 0, that makes this additive term 0. That makes my life easier. So 1/2 A times 2.6 squared, where A was 10.4 in the previous problem. So solving for D, I would be doing 1/2 10.4 times 2.6 squared, and that gets me my 35.2 meters. Solving the other way would give you the same answer, or at least close enough. This car accelerates faster than gravity because its acceleration is 10.4 and gravity is 9.8. Last page. Okay, 5A. I probably should have put this as one of the relationships to start so that you have an equation to go with it. If you have 10 stories and they're 3.3 meters each, that gives you 33 meters. And now let's do our knowns and unknowns. So things I know. I know it's dropped from rest. That is a key word you should find whenever you find that word. Put a little circle, star, hearts, I don't care what you put on it, but notice the word. Rest means 0 meters per second. The distance is 33 meters. Someone wanted to know the acceleration. This is an object in free fall, so I can use the 9.8 from the previous page. And now I have enough to solve. I'm looking for the final velocity and the time. Put a little box around those so I know what to look for. And so for part B, I want an equation that has the velocity, distance, acceleration, but does not have time. And there's only one equation that has that. That's equation 3. VF squared equals VI squared plus 2AD. So that's 0 plus 2, 9.8 times 33 is equal to VF squared. Or in this case, that's VF equals the square root of 646.8, or VF is 25.4 meters per second. And I haven't been modeling step 4 terribly well. Step 4 is to check if this makes sense. 25 meters per second, I want you to keep that number in the back of your head, right? That is really close to your highway speed, like 60 miles an hour. Does it make sense if you drop a ball from the top of a 10-story building that it hits at 60 miles an hour? Yeah, it really does. A 10-story building, that is a non-negligible building. That is pretty big, so I would expect it's going pretty fast. And for the time it takes to fall, now that I found B, I can use either of the other 2 equations to solve that, so I might as well choose the easier one, right? If I have to solve equation 1, that is easier for me to solve than trying to solve equation 2. In fact, if you tried to solve equation 2 for time, you might even have to do the quadratic equation because you have a t squared and a t. So, you could totally do that. It is solvable. I made it so you don't have to solve for the quadratic equation this time because VI is 0, right? But we just don't want to do that. That makes my life harder. Why would I do that? This I can solve really easily. So it's going 25.4 meters per second with an initial speed of 0. This is 25.4 divided by 9.8. And I can't quite do that in my head, but I can pretty close, right? It's like almost dividing by 10. It gets us 2.59 seconds, which is reasonable. A ball to fall for, 2.5 seconds for 10 stories, that sounds reasonable. If it was 2.5 minutes, I would think that's not cool. It would not work. Last one. In this problem, I just wanted you to practice substituting and solving. So for car A, I know velocity, time, and I want acceleration. For car A, I know its initial velocity, its final velocity, its time is 4, and I want acceleration. So for car A, I'm going to use the easiest possible equation, equation 1. So that's 27 equals 0 plus A times 4. 27 divided by 4 gets me that 6.75 number. But B, if if I do my knowns and unknowns, I have the same speeds listed, right? But that's weird because I have the distance, not the time, and I want to find acceleration. In 45 meters of distance, like half a football field. The only equation that has both velocities, distance, and acceleration, but does not have a time term, is equation 3. So Vf squared equals Vi squared plus 2AD. Substitute and solve, so that's 27 squared equals 0 plus 2 times 45 times A. So I'm dividing 90 to the other side, and that gets me 729 over 90, or an acceleration of 8.1 meters per second squared. So that carb B has greater acceleration than A.